Alright, so this video is going to be on neutralization reactions. So neutralization reactions are reactions or are a type of double replacement reactions. Okay, so if you remember from double replacement, it's when the reactants or one of the part of a reactant switches place with another part of the other reactant. Alright, so in a neutralization reaction, it's going to be between an acid and a base, and the products are always going to be salt and water. So it's going to be acid plus base producing always water plus salt. Okay, and for salt, remember, it doesn't have to be NaCl. NaCl is not the only salt in chemistry. In chemistry, a salt is any ionic compound. All right, it must be ionic. By ionic, we mean it must have a cation or metal and an anion. Okay, so it's an ionic compound with a cation and an anion. Some examples of salts include NaCl, which you already know, sodium dichromate, and copper 2 sulfate. These are all ionic compounds, aka also known as salts. Alright, so this is the key important information here. It's going to be acid plus base producing water plus salt. Right, so our example, I'm gonna do these, I'm gonna do 4 examples with you, and let's see how we do. Okay, so the first one is the question is asking us to write the overall equation for a reaction, for a neutralization reaction. So it's a reaction between solutions of hydrochloric acid and sodium hydroxide. All right, so in this, the first example here, the chemical formulas for the sodium hydroxide and hydrochloric acid are given to us. If for any reason that you are not given the chemical formula, remember you always have table K and table L, which give you the names of the common acids and bases. I'm not gonna give you any acid or any base that is not part of these tables. All right, and the acids and bases involved in neutralization reactions are always going to be Arrhenius acids and bases. Okay. All right. So the first one here is NaOH reacting with HCl to produce salt and water. Right. So salt, that we're gonna find, and then water. Water, we know what the formula for water is gonna be. Right. So since you will always have water, it's always going to be H2O, and then plus you have to find the salt. And so let's see how we got H2O in the first place. So here it's a double replacement reaction. Neutralization reactions are double replacement reactions. Keep that in mind. Always, always, always. Right. So you have the hydrogen here is going to switch places with the Na. The Na is going to take the place of the hydrogen. Okay, so when the hydrogen switches places with the Na, the product is gonna be HOH or H2O. Look, wow, we got our water. And then for the salt, it's gonna be when Na and Cl react combined to form the product, the salt. So for double replacement reactions, right, when you write the chemical formula for a product, remember to keep in mind that we learned in the first term how to write the chemical formula or of a when two ions react. So here you have Cl minus and Na plus. Right? Remember, you always in an ionic compound, you need to have a balanced. You have to balance the positive and negative charges in order to get a neutral compound. So here you have one minus, you have one plus, and the ratio between the Na and Cl is going to be 1 to 1 because 1 minus 1 plus will cancel out, giving you an overall charge of 0. So it's going to be 1 to 1, it's going to be NaCl. And then here, there is no need to balance, everything is balanced, right? You have, you have two H's, one, two, you have one O, you have one Na, you have one Cl. Everything is balanced, we're good. The next reaction here is between solutions of carbonic acid and sodium hydroxide, right? So I feel like these kind of questions is what throws some students off. So let's see why, right? So remember that this is a double replacement reaction, right? Where the reactants, parts of the reactant switch places. So you have Na will switch places with H2, and H2 will switch places with Na. Alright, so remember, one of the products is gonna always be water. Right, so now when you see this, when you write water, when you see the H2 is gonna replace the Na, you're gonna be tempted to write H2OH. No, you can't do this, right? Because water has a formula of H2O, right? We're gonna deal with this 2 here after we write our complete reaction by balancing it. Once we balance, then we're gonna get the correct number of hydrogens. So right now you're gonna be tempted to say, oh, but here you have 2 hydrogens. How come when we write water we only write one? We only add 1 hydrogen to the OH. The reason is, if you write H2OH, that's not water anymore, right? That's some other substance, right? So for water it has to be H2O. So you're gonna switch, the hydrogen is gonna come here to and react with the OH to replace the Na to form water, H2O, right? So don't worry about, oh, we have 2 H's here, how come we're only adding 1 H? The reason is we're gonna balance the reaction at the end. That's how we get our correct number of atoms on each side, right? Okay, so now let's go to the next product that will be formed, which is when Na replaces H2, right? So remember that, so let's look at this reactant here. This reactant, right? This reactant here has 3 different elements from chemistry 1, from last term. Remember that when you have more than 2 elements, or more than 2 different elements or atoms in a compound, that means there must be a polyatomic ion in the chemical formula, right, or in the compound. A polyatomic ion is involved. So in this case, the H2 is the element that was replaced. CO3, if you look at table E, you will see that CO3 is one of the polyatomic ions. And if you look at the charges, or the charge of CO3, did I say CO2 again? Okay, sorry if I said that. All right, so CO3 is one of the polyatomic ions, and if you look at the charges for CO3, the charge for CO3 is going to be 2 minus. Okay, again, since this is a salt, since we already formed our water, now we need to form our salt to write the formula for the salt. Right, so you have CO3 2 minus, and then the other ion that's going to be combined, or that's going to be reacting with CO3 to form the product, is Na. Na as an ion has a charge of 1 plus. Okay, so remember, This is an ionic compound. This is a salt, which is an ionic compound, which has an overall charge of 0. It must be neutral. So we have to balance the charges. Here you have a 2 minus for the CO3 ion, pi atomic ion. You have a 1 plus for Na. So what you have to do here is you have to balance the charges. So since you have 2 minus here, you have 1 plus here, you need to add 1 more plus. How do we add 1 more plus? By adding 1 more Na. Okay, so you're gonna need 2 NAs to react with 1 CO3 2 minus to form the product with the salt. So our product is gonna be Na2, because we use 2 NAs to balance the compound, or the charge of the compound, Na2, and then the atomic ion CO3. Right, so it's gonna be, you have 2 pluses, 1 2 minus, they cancel out. So 2 plus plus 2 minus, they cancel out, giving us a charge of 0, which is the overall charge of this compound, of the salt. Now, usually the questions are not gonna ask you to balance, but if they ask you to balance, then you have to, you have to balance the atoms, right? So I'm not going to balance here because for acid-base neutralization reactions, we usually don't ask you to balance, right? But we'll go back. We'll come back to it in a few. Okay. So you know what? Let's just balance it since we're already here. Okay. So I'm gonna erase this so that I could actually balance. Right. So to balance it, balancing. You're gonna look at, let's start with all the atoms other than hydrogen and oxygen. So you're gonna start with any atoms other than hydrogen and oxygen. So here you will see an A, there are 2 of them in the product side, but if you look at the reactant side, there's only 1. So to balance it, you're gonna write a coefficient of 2 in front of the Na. So now you have 2 NAs, 2 NAs. Now let's count the other elements in the reactant product side. Carbon, you have 1 and you have 1, so carbon is balanced. Oxygen, right, you have 3, 4 in the reactant side, you have 3, 4 in the product side, so you're balanced. Hydrogen, you have 2, 3 in the reactant side, but you have, oh sorry, excuse me, I messed up here. Okay, this is a common mistake that students also make, so learn from my mistakes. Okay, so you see what I did? I didn't distribute this 2 after a balance. I didn't distribute the 2 to both the Na and the OH, or the O and the H. Okay, so let's do this again. So you have 2 NAs, you have 2 NAs, you're good. Now let's look at the carbon. Carbon, you have 1 carbon, 1 carbon, you're good. Now let's look at the hydrogen or oxygen, doesn't matter. So I'm gonna look at the hydrogens. I have 2 hydrogens here, and then I have 2 times 1 hydrogen, so 2 hydrogens in this overall, in this molecule here, after the coefficient. So you have 2 hydrogens, that's 4 hydrogens, but here I only have 2, so I'm gonna have to add a coefficient here of 2. Now once I do this, this coefficient is not gonna just change the number of hydrogens, it will also be distributed to the oxygen. So in total, we're gonna have 2 oxygens here too. So so we have 2 oxygens here, and this compound here has 3 oxygens, so 2 oxygen plus 3 oxygens, that's a total of 5 oxygens. In the reactant side, let's count the number of oxygens. We have 2 oxygens here, because 2 distributed to the O is going to be 2. And then here you have O3. This is O3, 3 is a subscript. So plus 3 oxygens. So it's going to be 5 oxygens. So the oxygens are balanced. Everything is balanced now. Right, so just make sure when you put a coefficient, you distribute it to all the atoms when you calculate how many of each atom you have on each side. Because as you saw, I made that mistake and I was starting to I knew something was wrong because it wasn't working out. Balancing should work out at the end when you balance. If it doesn't work out, you probably did something wrong and you have to go back and double check your work. Okay, so this is the complete balanced reaction, H2O plus Na2CO3. But you only do this if the question is asking you to balance, to write a balanced chemical equation or chemical reaction. If it doesn't ask for a balanced chemical reaction, you'll be good by just writing the products without balancing. Okay. Third example here. What are the products when potassium hydroxide reacts with hydrochloric acid? Okay, potassium hydroxide. You should know how to write the formula for this. Is potassium, it's K, and hydroxide, OH. K is the positive ion, which has a +1. Hydroxide is a negative ion, which has a -1 charge, right? And it's going to be a ratio of 1 to 1, KOH. If you don't remember how to do this, remember you have table K and table L. If you are only given the names without the chemical formula, you can always refer to table L, table K to get the formula. So potassium hydroxide is right here. It's the base. Potassium hydroxide is KOH, which is exactly what I wrote in here. The next, potassium hydroxide will react with hydrochloric acid. Hydrochloric acid, by now you should know, it's HCl. If you don't know, go to table K. This is the first one. All right, so let's write our reaction. It's going to be acid plus base, so HCl plus KOH. They will produce. All right, so right away you know this is a neutralization reaction because it's between an acid and a base. All right, and remember, these are double replacement reactions. So in this double replacement reaction, the K will replace the H. The H will replace the K. All right, so H and OH, this is gonna be your water, right? OH and H is gonna be water, which is always one of the products, plus the salt. You're gonna form a salt. The ions involved in forming this salt or ionic compound are K and Cl. Potassium or K has a charge of +1, Cl has a charge of -1. Alright, so it's gonna be K plus Cl minus. It's 1 to 1 ratio. The charges will balance out when you form the compound, so it's gonna be KCl. Alright, so it's gonna be KCl. This is our salt, potassium chloride. Okay, and let's see, is everything balanced? You have 2 H's, you have 1 Cl, you have 1 K. So we're good. But again, it didn't ask us to balance it, but I checked for balancing anyway. Last one, okay, before moving to titration, is CaOH2 plus H2SO4. You should try to do this on your own, and pause the video and then come back for it. See how I'm gonna do it. All right. So let's see. So you have CaOH2 plus H2SO4. Right away, this is a base. Okay, it has OH, H2SO4. This is an acid. Why? Because it has an H, and also you should recognize it. It's sulfuric acid. It's one of the common acids, and the name of it is right here, sulfuric acid. Right? And calcium hydroxide, let's see, yeah, it's right here too. It's in the common bases. Right? So if you don't remember the names, you have table K and table L. All right, let's see the products. Again, your hint, the thing that will make your life easier is always to remember that, I'm gonna delete this. Okay. The thing that will make your life easier is to remember that the hydrogen will always react with the OH to produce water. Okay, so let's see our replacements here. The hydrogen will replace the Ca. Okay, and the Ca will replace, I'm gonna use the blue. Okay, and the Ca will replace the, okay, what's going on here? The Ca will replace the hydrogen. Okay, so do it again. All right, so H and OH, these will always produce water. Don't worry about balancing, we will balance it later. So don't say, oh my god, we have H2 here, we have OH2 here. How come we only write H2O? This works out when you balance it, right? Otherwise, just know your product is going to be water. The other one is you have Ca and SO4. So again, remember when you see a compound with 3 or more different elements in it, that means there is a polyatomic ion involved, and you have to go to table E to find the charge of that polyatomic ion. So if you see here, you have hydrogen, and then the polyatomic ion must be the SO4. Okay, so if you look at table E, you're gonna find SO4, and it's gonna have a charge of 2 minus. Okay, and then in your, so this is gonna be the ion, and the anion, and then the cation to form the salt or the ionic compound is gonna be Ca, because Ca replaces the H2. So Ca, or calcium ion, has a charge of 2 plus because it's a group 2 element. Alright, so let's look at the charges. When you form the compound, you have 2 minus, you have 2 plus. The ratio is going to be 1 to 1. The product formed is going to be CaSO4. This is your salt or ionic compound. Right, so it's going to be plus CaSO4. And that's it. This is your neutralization reaction. Right, if the question asks to balance the reaction, right, so let's see what we have here. If the question asks to balance it, then you balance it. Otherwise, don't balance it, because you're not required to balance if it doesn't say balance. Write a balanced reaction. Right, so you have, let's start with the compounds other than water, other than hydrogen and oxygen. Ca. Also remember that for the proatomic ion, you're going to count it as 1 unit, because you don't count S as a different element, oxygen as a different element. SO4 is going to be 1 unit. Alright, so let's count. Okay, so in the reactants, we have hydrogen, we have oxygen, and we have SO4, we have Ca. Okay, in the products we have hydrogen, oxygen, SO4, Ca. So let's start with everything other than hydrogen and oxygen. Ca, you have 1 here, you have 1 here, you're good. SO4, you have 1 here, you have 1 here, you're good. And then hydrogen, so excluding, we're gonna be excluding the oxygens in SO4. Okay, hydrogens, let's count. We have 2 here. In the reactant side, we have 2 plus 2. So we have 4 hydrogens in the 4 hydrogens in the reactant side. In the product side, we have 2 hydrogens. So I'm gonna put 2. To balance the amount of hydrogen in the reactants and the products, I'm gonna need to multiply this by 2. So I'm gonna add 2 as a coefficient in front of the H2O. This now will change the number of hydrogens from 2 to 4, because 2 times 2 is 4. Right, so the hydrogens are balanced. Now for oxygens in the products, you're gonna see that I multiplied it by 2, so I have to distribute this 2 to the whole compound, to the whole water compound. So I have 2 oxygens, 2 times O, it's 2 oxygens. And again, don't worry about this oxygen here, because we already counted it in the SO4, because it's a polyatomic ion. And then here in the reactant side, we have 2 oxygens, because the subscript for OH is 2. And just like that, our reaction is balanced. So we have 1 SO4, 1 SO4, 1 Ca, 1 Ca. I should have put these numbers down for the SO4 and Ca in the beginning, but I forgot. But either way, this reaction is balanced. Okay, so the balanced reaction is going to be CaOH2 plus H2SO4, producing 2H2O plus as O4. Usually the balancing for these is going to be pretty simple, okay, for neutralization reactions. But if it doesn't ask you to balance, you don't need to balance, right? As long as you know how to find the products, you're good.